Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 2. Let's get started. For our exercises today, what we're doing is using what we learned in Lesson 1 to write expressions and equations, and then we're going to decide whether they are linear or nonlinear. Linear equation would be the sum of constants and products of a constant and an x that's raised either to the 0 power or the first power. So an example, let's look at number 1. The sum of a number, so I'm going to say, let's use a for a number. That's something we don't know, so we've defined our variable. The sum means it's going to be an addition problem, so this is a plus 4 times that number. That's 4 times a. Okay, so we're going to, our expression a plus 4a is the sum of a number and 4 times the number, a plus 4a. And this is a linear expression, and the reason it's linear is we have the sum, so we see that we have an addition problem. The sum of a constant, so here's our constant, let me get another color here. Here's our constant 4, and a variable. Okay, the sum of a constant and a variable, here's a variable, and the product of a constant where the exponent is either a 0 or a 1, and in this case the a is raised to the first power, which just makes it a. So this is a linear expression. The thing that would make it nonlinear would be if either of these variables had an exponent that was greater than 1 or less than 0. So if for example, if we had a squared plus 4a to the negative 5, maybe something like that, that would be nonlinear, and what makes it nonlinear is the square, that's an exponent greater than 1, and this also makes it nonlinear, an exponent that is smaller than 0. So those would make it nonlinear, which just means when we graph these expressions, when we graph the equations, when we get those, it would not be a line, it would not be a straight line. But this one would be. That one is linear. Okay, let's try a few more. The product of 5 and a number. Well, the product of 5 and a number would be 5n, if we said n was the number that we didn't know. And we can see that the exponent would be a 1, so this is a linear expression. Number 3, multiply 6 and the reciprocal of the quotient of a number and 7. Well, let's call the number x in this case. And look, it's asking for a quotient, so that means the answer to a division problem. So my division problem is x divided by 7, but then it tells me I want the reciprocal of that. So the reciprocal would be 7 over x, and we're going to multiply that by 6. Multiply 6 and the reciprocal of the quotient. So this is 6 times 7 over x. 6 times 7 over x. And that is a nonlinear expression. The expression is nonlinear because the number 7 over x equals 1 over x. Okay, 7 over x is equal to 1 over x, which is, 7 over x is equal to 7 times 1 over x, and 1 over x is equal to x to the negative 1. And since our exponent is less than 0, then this is a nonlinear. So this is nonlinear. If we were to graph this, if it was an equation, and we graphed it, it would not be a straight line. Okay, let's get that out of the way so we can do number 3. Okay, so this one's nonlinear. Number 3 is multiply 6 and the reciprocal of the quotient. That's the one I just did. Okay, we're good. My bad. 3's done. Let's go to 4. Twice a number subtracted from 4 times a number, comma, and then added to 15. All right, so let's unpack this one. Twice a number subtracted from 4 times a number. So I'm going to start with 4 times a number. So 4x. And then I'm subtracting 2 times a number, so that's minus 2x. And that is all added to 15. Okay, so we have 4x minus 2x plus 15. If I simplified this, 4x minus 2x is 2x and plus 15. 2x plus 15, I can see I don't have an exponent that's greater than 1 or less than 1, so this is linear. This is a linear expression, so that one's good. Number 5, the square of the sum of 6 and a number. Sum means addition. I'm going to add 6 plus x. And then I'm going to take the square of that sum, the square of the sum. Okay, so in this case, we have an exponent that is greater than 1. So this automatically makes it nonlinear. As soon as you see that, it's nonlinear. Any exponent greater than 1 or less than 0, any negative exponent makes it nonlinear. Number 6. The cube of a positive number divided by the square of the same positive number. So we have a division problem. So I'm going to take the cube of a positive number, x, that I don't know, that's x cubed, and I'm going to divide by the square of the same positive number. So that's x squared. And x cubed over x squared, when you first look at it, might look like it's nonlinear, but if we simplify it, x cubed divided by x squared is equal to x, because we subtract the exponents to get x to the first, and that is linear. So number 6 is a linear expression. Okay, number 7. The sum of 4 consecutive numbers. Okay, so 4 consecutive numbers we're going to add together. I don't know the first number, but I'm going to add it to the next consecutive number, which is 1 bigger, so x plus 1, plus the third consecutive number would be x plus 2, and the fourth consecutive number would be x plus 3. Okay, and then I can add all of these up. I have 1x, 2x, 3x, 4x's, so that's 4x plus 1 plus 2 is 3, plus 3 is 6. 4x plus 6. My exponent is a 1, so this is linear. All right, number 8. 4 subtracted from the reciprocal of a number. So if I had a number, if the number is x, the reciprocal of that number would be 1 over x, and then we're going to subtract 4 from that, so minus 4. 1 over x minus 4 is our expression. And it looks like, yeah, it's good, right? There's a 1 exponent, so it looks like it's linear. But remember, when we take the reciprocal of 1 over x, that's equal to x to the negative 1 minus 4. And now our exponent is less than 0, so this is nonlinear. All right, nonlinear. And let's see, our next one, number 9. Half of the product of a number. So product means multiply. That's the answer to a multiplication problem. product of a number multiplied by itself 3 times. So the product of a number, x, multiplied by itself 3 times means to the third power, x to the third power, and then we're going to divide that by 2. So x to the third divided by 2, and x to the third divided by 2 is nonlinear because that exponent is greater than 1. So this is nonlinear. All right, getting the hang of these. Number 10, the sum that shows how many pages Maria read if she read 45 pages of a book yesterday and 2/3 of the remaining pages today. So I don't know how many pages of the book, so that's going to be my variable. So I'm going to say that's x. So if she reads 45 pages yesterday and 2/3 of the remaining pages, we would have 2/3 of the book plus the 45 she read on the first day. So 2/3 x plus 45. And this is good, where our exponent is a 1, so this is linear. Okay, number 11, an admission fee of $10 plus an additional $2 per game. I don't know how many games, so that's my variable. So we'll call that x, and we're going to say it's $2 for every game plus an admission fee of $10. My exponent is a 1. This is linear. All right, it's that simple. We just need to write the expression, check the exponent. Number 12. 12 is 5 more than 4 times a number. Okay, so we want 4 times a number. So that's going to be 4x. And then 5 more than that. So that's plus 5, 4x plus 5. And then twice that sum. So I'm going to multiply all of this by 2. 2 times 4x plus 5. If I simplify using the distributive property, I would get 8x plus 2 times 5 is 10. 8x plus 10, my exponent is a 1. This is linear. Okay, there you go. That is lesson 2. Hope that helps. See you again next time.